Why do the practitioners of DDD and DDD purists insist that we should always make wrappers around EF Core to make it more DDD-like? EF Core was built with DDD in mind. All DDD-style patterns you might ever need are already implemented there, so why add implementation around it? Now, talking is cheap. Let me show you my code. I have prepared a very simple example. This is the main model, modeling an invoice. I'm sorry, I'm out of ideas. Anyway, the invoice contains a collection of invoice lines. The invoice line is equally simple, but it references a product domain class. You may already start noticing some things that are not DDD-ish. You might complain, and I will change this model to make it more in line with the DDD, the principles of DDD. The product is just scalars. And so we get to EF Core. This is vanilla DB context, nothing special in it, just these three entities configured. It is exposing DB set per entity, and that is where DDD begins. The first concept is about aggregates. I will say that the invoice with invoice lines is one aggregate, and the product is another aggregate. Aggregate definition begins with EF Core configuration. These parts should go together. They will configure one aggregate. And there is the native support for configuring aggregates in EF Core. You would create a configuration class per aggregate. Put everything concerning invoice aggregates here. You might be tempted to load the entire aggregate by putting auto-include on the invoice lines entity, which belongs to the invoice aggregate, because there should never be lazy loading within an aggregate. However, keep in mind that queries, which are a separate concern, should not include entities they don't use. There are various queries in the project. And so I will remove auto-include for now, and I will explicitly include the detail entity when loading the aggregate specifically. You will see that. A similar configuration class would define the product aggregate. So when we return to DB context, we don't need any of this code. Simply register one configuration class, then another, and both aggregates are now configured. The next big question in DDD is persistence ignorance. Most obviously, the surrogate key is visible in all entities in my model. It is common in DDD to remove database-generated keys. This model is much better because now you cannot tell how it is going to be persisted. Is it the relational database? Is it document database? Is it EF Core behind? You cannot tell by just reading this class. I will do the same in the invoice line, but I won't stop there. I will also remove the foreign key pointing to the invoice. The contained invoice lines will be tracked via the collection in the invoice, and that is how we are going to access them. The same in product, and no more database IDs are visible in any domain class. So we need to visit EF Core configuration again. You can declare an ID as a shadow property, so it will be there in the database, it will be there in the change tracker, but you won't see it in the model class. I'm using the string name of the foreign key column, so to keep it away from the in-memory model. Invoice line entity, which is contained in the invoice aggregate, would also require its own configuration now, and I would do the same change in the product configuration. IDs are now EF Core's concern, not domain models. So we have solved another DDD concern. Let's address the next one, cross-aggregate references. It is not allowed for an entity inside one aggregate to directly reference an entity in another aggregate, because that other entity wouldn't be loaded in memory together with this aggregate. That is one of the core principles of DDD. This design principle requires some kind of public reference or public ID that we can share among aggregates. It is common to introduce some public ID for this purpose, which is separate from the database ID. Database ID is the database's technical concern. We are really not interested to know it. And then comes another practice. It is very common in DDD to define a strong type for this ID or this key. You can expose a useful empty singleton or a static factory method that creates a new key. But the important part is that the aggregate root would now expose this key or ID for referencing purposes and public APIs. That is the ID this invoice line model will contain. By using the strongly typed ID, you're dismissing the possibility of assigning a wrong GUID. So I have completed the invoice line entity contained inside the invoice aggregate. Its own aggregate root would follow the same pattern. There would be a different public ID type for this aggregate, and there will be the property that contains it. Time to pay another visit to EF Core. How does it support this? EF Core supports GUIDs natively, but not a record that contains a GUID. However, EF Core supports value conversions. This class would convert between product ID and a GUID. A GUID goes into the database, a product ID goes into the in-memory model. You would simply provide 2 lambdas for each of the conversion directions, and you are done. Use this converter when configuring the public ID property, and that is all. I'm sorry, that's not all. There is one more thing that EF Core supports. It also supports alternate keys. You can declare this public ID as alternate key. So EF Core will make it unique, immutable, and it will let you use it as a foreign key in joins. There will be no visible performance penalty when using a GUID like this. So we need to configure that foreign key in the invoice line configuration. Define the product ID as a proper foreign key with index and everything, and tell EF Core to use that same conversion for this field. You see already how that works. I will repeat the same pattern for public ID in the invoice. Other entities will now be able to reference invoice aggregate the same way as invoice line has referenced the product. DB context is already configuring all entities in all aggregates, and that leaves us with the last element of DDD which I want to show you in this video. CQRS, Command Query Responsibility Segregation. But before I show you that, please let me steal a moment of your time to remind you that this channel and everything you can find on it is free, but only thanks to the patrons, the people who are financially supporting this channel. I'm very grateful to every patron, and if you want to also help me maintain this channel and keep it free forever, then please join the growing community of patrons on my Patreon page. You will find the source code of this video and all other videos there, and you will also find some goodies and offers that are not available on YouTube alone. Thank you very much. Sorry for this interruption. Let's get back to code, where I want to show you how CQRS works in an application that uses EF Core and follows the principles of DDD. This is one typical command, adding a single line to an invoice. It is a typical practice in DDD to find a single aggregate by its public ID, and that would be the invoice. So we start from invoices, include all entities that are a part of the aggregate, and then we isolate a single aggregate root by the alternate key in EF Core. This is how EF Core supports loading a single entire aggregate. The rest is straightforward. Perform the domain operation. While dbset was the repository, the db context is the unit of work, so we commit changes by calling save changes on it. Produce the HTTP result, and this makes one complete typical DDD command. Queries are different in sense that they cross the aggregate boundaries. For example, this query is supposed to sum up the quantities of materials included in all invoices. Therefore, query the materials, join them with invoice lines that reference those materials, group them by material ID and sum up the quantities, collect the results and produce the HTTP response. This query is using rows from two aggregates, which is typical in queries in CQRS. While commands will operate on a single aggregate each, queries may easily cross aggregate bounds to get the data they need. And as you can see, by using link to entities as a specification, you can harness the native support for queries in EF Core. There is no reason to build your own specification. That would mean you would design an entire link, but for what purpose? Link already exists. You don't need your own custom link, whatever. Now, if you want to remove link to entities from application, which is again a valid concern, just give this entire query a name and put it somewhere else in the infrastructure layer. This code shows how EF Core supports fundamental DDD patterns. It's not complete yet. I will leave the rest to your imagination or to your practice. Just try to pull these elements where EF Core is still visible in the application, pull them back into the infrastructure layer and solve them there. That would just move code that will not create new implementations. The implementation is already written. What I wanted to show you is that you would configure each aggregate individually and then use DB sets as DDD style repositories, use DB context as unit of work, and use link to entities as specifications. All that remains is just to hide them behind some interfaces that simply remove your custom implementation from the application, and that's it. You will have complete persistence ignorance in your application and in your domain model. And that was the point, wasn't it?